no more workshop in the future. But we also take survey to see what everyone like, and we can ask more people to do workshop. But today, so because the new HPC is coming out very soon, so I think it's very crucial for someone from the HPC to present the talk first. And then today we have Nadia Williams. So she's from the HPC, and she will going to give a talk for us. Thank you so much, Nadia, for doing the talk today.
Thank you for the introduction. I see we have about 40 people. So I suggest I start talking and it will be slides, and I will pass to you guys the PDF copy of the slides in its entirety. So it will be easy to follow and use. And I have a lot of links in the slides to our website and all the guides. And perhaps we can go to the questions after I finish talking, unless there is something very pressing, then maybe somebody can put it in chat, and then you two, Remy, and you can actually ask the questions. Otherwise, it might become a little bit complicated to hold everything. So with this, I will just, I believe I will just start. Let me share the screen. Okay, can you see the slides?
Yes.
Okay. Oh, and it's not going. Why is it not working? Okay, here we go. So we have just a few items on agenda, and I tried to split them in just 4 categories. The first one will be what are the differences between HPC3 and HPC. Then we'll touch on basics of Linux and Shell that are necessary for running your jobs. We'll talk a little bit about modules and programs and differences and what the modules and programs are and how to deal with them in your own user environment. And finally, we'll go with how to run jobs on HPC. So some background, many of you, I believe, were already using HPC, and now all of those users will be moved to HPC3. HPC and Green Planet catalyzed shared computing at UCI, and at some point there was a survey of the users that indicated that it's important for faculty for research and for teaching, and it's overall very useful. However, there is a lot of room for improvement. And currently, scalability of HPC reaches limitations in terms of queue access, and the operating system is already outdated. We are actually going to turn this cluster off at the end of this year. So there was a recent MRI award coupled with UCI campus investment that provided us an opportunity to create additional cluster. And this is the one that we call HPC3 that we will be using for research. Well, the goals of HPC3 remain quite simple. We want to enable users to have access to much larger compute analysis system that they cannot possibly afford on their own. You might have a single server in your lab or your own server that can have quite a few CPUs or maybe even GPU, but you still cannot get access to many, many nodes as we can provide with the cluster. We also provide access to specialized nodes with high quality 64-bit GPU and a few nodes with the large memory. And we try to foster a growing community across UCI that can utilize scalable computing, both high performance and high throughput for their research. We also want to provide a well-managed software environment that can form basis of reproducible and more secure research environment. That means we can actually reproduce the software versions, and we can bring it back when necessary as virtual machines. What is different as far as accounting? On HPC3, we have only 2 types of jobs: accounted jobs versus free jobs. Accounted job, once it starts, it goes until it finishes or until it errors out. Nobody can kill accounted jobs and nobody can preempt it. And accounted job, just as the name suggests, draws from your account bank. And I will talk a little bit more about your banking account. And then there are free jobs. These are not accounted jobs. They can start anywhere on the cluster when there are resources available. And they can be killed at any time by an accounted job. So what are the ways to fill your account? Usually when we talk about an account, there are two things. One is your PI lab account. Usually PI is granted special core hours, and then all the students and researchers in the PI group can have access to the cycles. This is what we call granted cycles. Another type of filling the account is what we call converted or condo style. The PIs or researchers can purchase hardware, but they don't go and purchase themselves. We actually ask them how much capacity the researchers need, and based on the answer, we purchase the hardware and then recharge the group index. We manage the hardware, we installed it, and we convert the hardware into core hours. And how does it work? Let's say that we buy a server for you, which has 40 CPUs. A single CPU can provide 1 core hour per hour, multiplied by hours per year, multiplied by number of cores in the server. That gives you total number of hours that this hardware can provide in a given year. And we take 95% of that and deposit into your account. Why 95%? There is downtime. For example, sometimes the nodes need to be rebooted. Sometimes there are hardware issues. Sometimes we need firmware upgrades. And there is also some portion of the CPU that goes into maintenance of the operating system and on the node running. All of this together comes to about 5% total. So physical hardware can actually deliver 95% of the hours. And PIs can also purchase hours, and the price roughly comes to about 1 cent per core hour. It's going to be even less expensive because these are bought in chunks of hundreds in incremental buys, and it can be added at any time. Queuing is very different on HPC3. Before, as many of you know, we had private queues, and people would, in a particular group, can have access to a few or many private queues. And when the queue is not occupied, these cores were taken as a part of free queues. And we had roughly 80 or 90 queues with honor preemptions, which was very difficult to manage, very inconvenient, and not necessarily scalable. In a new cluster, we have very, very few queues, and they are separated. We have a queue separation by capacity and by type. So for example, debug queue is reserved for very, very short jobs that needs to go, may not necessarily finish, but we'll just try and check whether your submission script is correct and whether everything else is going to start running. We have a standard queue, which is basically a single queue where all the accounted jobs are run. We have GPU standard queue, which is provisioned for jobs that require GPU. And we have a free queue. So basically, you have access to all of these common queues, including GPU and including high memory. And sometimes people are asking, well, I'm going to buy 2 nodes, and am I going to run my jobs on these 2 nodes? The answer is no, you're not. All the nodes are equivalent in this cluster. And when you buy a node and we convert it into core hours, you just are given this core hours, and depending on where at this point this core hour is available, Swarm scheduler is going to put your job on a specific node. So what are the major differences? On HPC, node owners' jobs can kill free jobs on their nodes, and on HPC is different. Only free jobs can be killed on any node. All accounted jobs continue working and continue until they finish. Previously, most users had an access to a small number of queues. Now users have access to nearly all the queues, and all jobs can span nodes as needed. Before, users could purchase hardware they wanted, and we were trying to install it and deal with it, and that proved to be not an optimal solution. So right now, what we do is we either grant users core hours, that's usually is coming for PI on a yearly basis. PIs can purchase core hours, and PIs can purchase hardware, which we convert into core hours. Basically, we buy the hardware because we already know what is good for the system, and then we recharge your group. The operating system is very different. CentOS on HPC as of 2 days ago is no longer supported. It came to the end of life, and this is why we have to switch this cluster off. Operating system on HPC3 is CentOS 7. In about a year or so, we are going to upgrade it to CentOS 8, so we keep up with the new development. Old scheduler was SGE and new scheduler is Slurm. It's different, but there are a lot of similarities as well. And for most of the users, translation of the SGE submit script to Slurm submit script should be a very easy task. There used to be so-called BLCR checkpointing on HPC. We do not provide any checkpointing on HPC3. That particular software no longer is developed. The development stopped in 2014, and it really never worked that well to start with. So we do not provide any checkpointing for any jobs. What are we trying to achieve with our few queues on HPC3? First thing is no over subscription. What does it mean? If you own 10% of the total cluster, your starting core hours account balance is 10% of the total number of hours that can be delivered by the whole cluster hardware in a given year. And that's what you can use. You can use it all at once in small increment, however you use it. And once you use it all, you will have to replenish it. We also want to achieve fair queuing. What it means, no first in, first out. Jobs that arrive earlier in the queue are not guaranteed to schedule first. Why? Because we want to prevent a larger number of jobs from one user to block a small number of jobs from another user. Therefore, scheduler will decide when particular job can go in. If you're a user who submitted thousands of jobs and then you sit and wonder why some of my jobs don't go when there are free nodes available, this is why, because we're reserving some portion of the queue for the users who may come with small number of jobs. We have a bias towards interactive turnaround for small debugging jobs, and this is in order to optimize people time for debug process, because you don't want to sit and wait for hours to see if the queue is available, because you want to check some submit script. You want a really fast turnaround, and for that purpose, we create a debugging queue. We also want fair running. If you're running an account, a job, nobody can kill your job. Once a job is started, it cannot be preempted, it cannot be removed. The only way this job can fail is if there is a hardware failure or there is something wrong with your job workflow, and for whatever reason, the program halted or ran out of memory or something like that. Otherwise, no job preemption. And there are free cycles, and users who pick up free cycles can run their jobs, but they have to be aware that the jobs can be killed if and only if an account job comes in and there are no other CPUs available and the job needs to be run as soon as possible. Only then the free job gets killed. So when are we moving from HPC? We actually have been moving from HPC for a while right now, since April, and we had few alpha and beta users who were helping us to start and iron out some details. All existing accounts will be transferred to HPC3. Right now, we have been moving groups and labs, and we started moving individual users as soon as they requested. And by the end of the year, we will move all the accounts to HPC3. Please see the link that I'm referring to here, and it tells about how the move is done. Now, we are not going to move your home directory from HPC. These two systems are very different. You will have to transfer important files from your home directory yourself, either to one of the DFS systems that's available to you or to CRSP area. And it's better to do it sooner rather than later. The amount of space that is used in your home is not very big. It's roughly should be about 50 gigabytes or less. So it's not a big job to actually clean up your home directory and move what is important for you to the HPC3 system. Your files that are on DFS 3, 4, 5, and now 6, and on CRSP are already available on HPC3. We are currently rebuilding DFS 3. This is why many of the users areas will move to DFS 6 and DFS 7 temporarily, and then once we rebuild DFS 3 and DFS 2, we make additional move for some of the users. Those who are affected already have been notified and know about it, and we try to keep all the backups and all the copies so nothing gets lost in this transition. For the software, most of the software we try to make available on HPC3, and by most we mean this software that is used by many groups and many people. We keep a software map as an example on our website, and I will get to it in the next slide. If you compiled your own version of some software on HPC, you will have to recompile it on HPC3. Why? Because the operating system is different, compiler version is different, system libraries are different. Whatever you currently have on HPC has a very small chance of working as is, likely will not. Therefore, you will have to take care of it through recompilation of your preferred software. Now it gets to the software map. This is actually straight out of the software map that we posted on our website. It looks a little bit strange to you, but basically each of those rectangles is a software category. And division into software category is very approximate. It's just for our convenience that we divide it this way when we're building software. And for example, there are bio tools, there are chemistry tools, there are physics, simulations, imaging, and so on, few of those. And I'm enlarging here just one of these rectangles to show you what we mean by the software dependencies. Each rectangle is divided into two parts. One shows what this particular group provides, and another one shows what this particular group requires. Anything that is listed in either provides or requires, we have available through the use of modules. So for example, here under provides, you see BCF tools and then version, or BED tools and its version. And many of these tools require something that we have to build in order to compile these tools. That's why there are multiple requirements and multiple dependencies. We have to satisfy this all. How do you know what is installed? Once you log in on HPC3, you will have to use modules command, and I will get to it a little bit later. We often get requests about adding a new software to HPC or HPC3, and we must tell right up front that some software, it's not possible to move from the old cluster to HPC3 because the operating system is much newer, and some software is just simply too old for the new OS and will not compile or will not build. The versions of the software might also be different just because of the dependencies and the new OS. We try to keep as much as possible the same versioning, at least for some of the users, but sometimes it's just simply not possible. Now, some of the packages you will need to install yourself, and sometimes we are asked, well, why do we need to do it? Why can't you install it for us? Well, we have about 2,000 users on the cluster. If each one of these 2,000 will ask just for one package, we will have all our hands full just building the packages and will never end. It's simply not scalable. For the big language applications like R, Perl, Python, or for Conda, we actually install them for you. And for each one of them, we try to build a comprehensive library of the most used packages. And whatever is required for those software packages we already built. Outside of that, if the request comes from the lab, we usually try to honor it because many users can be affected. And if it's some esoteric package that a single user just want to try, we will ask you to try to do it yourself. And we provide a guide on our website that explains how to do it. It also explains how to experiment installing your own specific R, Python, or Perl, or what have you packages, and also explains how to do a software installation request and what information we really need from you when you're asking us to install the software. Now we're coming to basics of being a good citizen on the cluster, which is extremely important because cluster is a shared resource. It's not your own personal machine, and therefore it needs to be treated as a shared resource. Whatever people do actually affects other users and sometimes extremely negatively. And I'm sure some of you have experienced these negative things before. And that usually happens when someone decides to run an interactive job on login node, which we ask users not to do because obviously login nodes are for login and for job submission, but not for running interactive programs. We also ask not to transfer data on login nodes. There was a specialized node created for that. And we ask users not to bypass scheduler. What do we mean by that? All the jobs must be submitted through a Slurm scheduler, either with S-batch or on trying to access interactive node. If you are going to SSH to a node and simply start your computation there by hand, that's considered to be inappropriate use. Sooner or later, your processes will be killed. And if we have repeated offenses, then the account can be blocked. We really ask users to abide by our rules, and our rules actually quite simple. So for your job, we also ask users, please take a look at the jobs that you have already run and try to figure out how many resources you really need and don't ask for more. Often we see situation when a user submits a job and asks for 32 CPUs, and yet user is running a simple Python program. It may be complex, but it's simple in the sense that it does not do threads. It does not really use 32 CPUs. So basically what's happening in this case, you are using one CPU and 31 are idling, but right now reserved and system cannot use it. So you are basically blocking resources. So we ask users, please study this Slurm guide. We created a lot of examples there. We explain how to request multiple CPUs, how to request more memory, and we provide examples for specific applications as well. And this will give you some idea of how to submit your jobs. We also ask you to be mindful how to submit tickets, and the reason for it is we really want to help you and to support whatever research you're doing. But if we get a bad ticket, we can't really provide you with the help you need. So what do we mean by the bad ticket? I'm going to give you a few examples here. This is actually pretty much verbatim from some of the tickets that we receive. I'm submitting my job and my job script, and I think there is something missing in the script and I'm unable to find it. Can you look at it? Well, there isn't really very useful information here for us to look at it, so we have to go back, reply to you and ask, what was your submit script? How the job was submitted and what error did you get? This is the information that the user needs to provide upfront, so we don't waste time on this communication back and forth trying to figure out what actually is going on. In the second example, a user is asking, I'm running the jobs from the model and there is an issue with LibNet CDF and I'm unable to fix it. And this is the path where I'm running my job and more details in the screenshot below. Very often when people submit screenshots, they don't show properly in our ticketing system. So we actually have to download screenshots separately, then look at them separately, and then try consolidate with what you're saying in a ticket. And that takes much more time. And most of the time, screenshot is basically a screenshot of a few lines. What we are asking users to do is, again, tell us what was your submit script, give us full path to the submit script, and instead of the screenshot, please copy and paste those lines directly into the ticket. That would be much more optimal. Another information about accessing my connection get closed on login, please refer to the image below. Very often screenshot, even if it shows, it does have only partial info. So again, we don't have enough to go on to help you. You need to provide us with as much information as possible so we can get back to you and provide you with the help that you need. As far as the software installation, often we get the request that says, well, I need to run program X. Can you install it, please? It's very commonly used in bioinformatics field, and it's better to use it as a public module. And these are the instructions, sudo apt-get. We actually don't need the instructions how to install it. We need from you a URL and the version of the software you need. And we also need to know how big is your group and who will be using it. I already explained a little bit earlier that we can't possibly install every single package that users ask. We do try to honor group requests because many people are affected by it, but some very specific, very small applications are very easily installed by the users in the user area, and that's what we suggest people do. Sometimes people have trouble writing in their dedicated area, but example 5 here shows how the ticket was worded. And from this information, again, we can't really help you unless we know where are you working, on what node, what was the command, and what was the error. So please try to go to the website, read our user guides. I am actually showing a snapshot here, what user guides we have. We provide a lot of references, a lot of examples, and show some facts and how to ask for help. And if you have additional questions, please submit the tickets and we will be happy to help you. Now we're coming to the next agenda item, basics of the Linux and shell that are necessary for running jobs on HPC and HPC3. Well, the login really did not change that much. You just have to specify different server. This is HPC3 server. And SSH login is what we allow. I would like to ask everyone if you have created a passphrase for SSH public key authentication, this is great. Do not use empty SSH passphrase. It's actually not a good idea. And please use this link that I show here to figure out how to do public key authentication. It's very easy. You need to do it only once, and then you're good to go and with secure connection. If you plan to run interactive graphics programs, you need to provide additional keywords to your SSH connection. Usually it is X and Y, capital letters. Sometimes people use X2Go program. Some people prefer that, and I provide a link here that you can take a look at and see whether this is what you would like to use. Your shell is Bash on both clusters, old one and new one. And Bash is basically implementation of shell that has a built-in utilities for many commands that users execute. And it's also a command language interpreter that basically intercepts everything that you type either in a shell script or on a command line, and that is converted into the commands that computer will understand. Bash is a full programming language and is used in script, and Slurm and SGE submit scripts are actually partially using Bash syntax. Because you're mostly interacting with Bash, it is good to learn the basics, such as how to create and list files or directories, how to check your disk usage, maybe create a chain of commands or create aliases for shortcut of the commands, and much, much more. Some people sometimes do not obey the naming schema for files and directories, and this is actually extremely important to keep this clear. There are very few rules to remember. Names are case sensitive. Folder means a directory in a Linux world. Single dot means current directory, double dot means parent directory, and tilde is your home directory. When we are asking you to provide us with a full path to the script, we mean that it starts from the very root because the file system on Linux is usually like a tree with directories and subdirectories. A relative path means that it starts from the current directory where you are, but we never ask you for relative paths because we don't know where in your user area you start your job or place your script. It is extremely important to use only alphanumeric characters and dot, dash, and underscore for file or directory names. And please avoid all the characters that are listed on the last line here or spaces between the words. Why? Because many of these characters are reserved characters for Bash, and they mean something very specific. And it can be very confusing and very difficult to trace what errors might erupt from using these characters. Recently, about 2 months ago, we had a serious problem with one of the DFS systems where we could not synchronize it and the meta server was failing. And after very long debugging and trying to figure out what was going on, we found a problem. A user created files that had embedded %n in the file name. And it seems like it should be not a problem. However, it is because some programs and some servers take % as a directive for fprint statements, and that actually turned out to be the case. To avoid such calamities, please just simply use alphanumeric characters and you will have plenty of opportunities to make different files and directories. There will be no shortage of names. When we create accounts, we usually always, we provide you with Bash startup files, and those files are invoked and get executed, and you execute them with both interactive shell and non-interactive shell. The difference is actually quite small. Interactive shell reads and writes to a user terminal, and non-interactive shell is not necessarily associated with the terminal. It's basically what you execute as a Bash script. Interactive shell further can be login or non-login shell, and again, there is not too much difference here. Login shell is the first shell that you get when you log in on the terminal, either remotely via SSH, or you can do it locally when you execute Bash with specific parameter. And this shell will execute .bash_profile file, which is located in your home directory. Non-login shell is invoked from the login shell, and it happens every time when you type bash at the shell prompt, and every non-login shell execute .bashrc file, which is also in your home directory. So now you have these two files, bash profile and bashrc, and the question comes, why and when would I edit them, and what is the good place to do it? So use bash profile editing when you want to run commands that should run only once. For example, you want to customize your path. It's rarely needed, but it may be needed. And this is the file where you do it. And you can use bash rc file for the commands that should be run every time you run a new shell. For example, this is the file where you will create aliases. This is the file where you can create history commands. And this is the file where you can create custom prompts. What can you do in this file? For example, you can create an alias. An alias, basically, this is actually what it is. It's just an alias name for the command that you want to run. It's a shorthand naming for maybe multiple words that you don't want to type. For a current session, it can be executed from the command line. If you want a permanent effect, you put all these lines in your .bash rc, and down below you see lsrm. I would highly recommend for everybody to have this ls in their bash rc file. What does it do? This basically tells when you run remove command, ask to confirm before removing a file. And that's actually what will happen. And if you really want to remove file, you just confirm yes, and the file will be removed. If you really made a mistake and shall ask you, do you really want to remove? You can say no. What it gives you an opportunity to actually prevent yourself from accidentally removing some files, and that can happen to anyone. The other aliases are just examples here, and they're quite short. You can see that ls command can have multiple words in it. Some are more useful, some are less useful, and you can create as many as you need and whatever is the most convenient for you. The environment variable syntax is also quite simple. You have to use the word export, then the environment variable name and its value. It's a key value pairs. One thing to remember here that, for example, path is a special variable and it's already set for you by the system. If you want to amend your path, you have to execute the last blue line on the screen. If you do what is written as a red line here, you will simply overwrite your path and then you lock yourself out of all available commands that on the system. So be careful when you try to modify variables. Bash history command, many probably are already using it. It's a built-in for shell and it displays all available history of the commands that you have executed, including the line numbers. Depending on the configuration, can be 1 or 2,000 history lines that are kept. And this is actually just for your convenience. You don't have to use it, but it can be very useful. So if you type a history, you will get back a long output of lines of the commands that you have executed, and then you can reuse those commands. If you don't want to type something that is too long, you can just run different command by preceding it with exclamation, or you can do exclamation mark and last command that you want to execute. You can run history in a different way and so on. I find it quite useful in my everyday work, and I don't like to type long commands, so I use history to actually do the shortcuts. By default, bash history file is in your home directory, and it is used for saving a list of commands. You don't really ever need to look at it. You just say history, and that file will be used to output on your screen. Sometimes people have multiple sessions open, and by default, only the history of the last closed window is saved. To overwrite it, you can actually save current history from every window by use history-a, which means append. And this way you can save all the history of the commands that you've been executing for your next session. Custom prompt. Some of you have probably prompt set up as this very colorful line on the top of the screen. I find this a little bit complex for my personal use, so I prefer something much smaller and much more usable. So it actually gives me enough real estate to type my commands. How do you customize it? You can quite easily. I would recommend first to save your bash RC file before you're doing any modifications and then edit it. This way, if you made a mistake and lock yourself out of the system, you can at least send us a ticket and say, well, this is what I did. I messed up my bash RC file. Can you please restore it from me? I have saved it, and this is the file where I saved it. Or you can have 2 sessions windows and you do edits in one session and verify that it is working for you. And if it is not working in the older window, you can actually restore your file from this type of the backup. So the settings for the prompt are called PS1. And on the left-hand side, you see this very convoluted and complex line. And basically what it means here, whatever is in red outside of, whatever is in red color actually says, I want my prompt to list the host name, then a space, and then I want to say a line number for the history and followed by a space. In the last prompt, we actually add additional information as who is the user at what login node and put some square brackets. And you can customize it according to what you like and how you like it. The strange numbers and brackets outside of the red lettering, it's actually coloring of your prompt, and you can use different values here as well. Common commands, most of you already know most of these commands. This making directories, removing directories, renaming them, copying and removing files, downloading some files, trying to see view files on the screen as a standard out, and checking what directories you are in, checking the disk usage, doing top command to show information about currently running processes, and maybe timing commands and so on. For some users, it might be useful to learn about command called tree that actually shows you directory tree, and sometimes it's easier to see this way what your directory structure you have, and it might be useful for some people. Many commands have -h or --help options that explain how to use them, and many commands have manual pages for them. You just basically say man and command name, and you will get more information on the usage. The home directory has a backup. First of all, there is a quota on your home directory. The quota is set for everyone at 50 gigabytes. So try to keep it clean and organized and put there what's important for you and what needs to be backed up. Anything that is temporary as a temporary files or job outputs that can be removed, please use another area for this. As I said, home is ZFS file system, and we take snapshots, which is a big backup capability. And currently we schedule to keep last 8 daily snapshots and last 6 weekly snapshots. This can change in the future. This is just an approximation for right now. And the location of the home directory snapshots, it's still in your home directory. It is in .zfs snapshots, and this area is read only. Please do not attempt to put files there thinking that that may be how you do the backup. This is not how backup is done. We do the backups on your behalf daily, and backups are created as snapshots of operating of your home directory at that point. So let me show you how I can remove and restore a file from the snapshot in my home directory. Well, first of all, I have a file that was created on September 17. It's called out. I check its timestamp and then I remove it. and made sure that is not there. And then I am checking right now my ZFS snapshots directory to see what snapshots are available. The snapshots are named according to the date when they were taken and approximate hour when they were taken. So if you look at the first of the three lines under ZFS snapshots, you will see that there is a snapshots as of September 17. My file out was created at around 3 o'clock in the afternoon, and snapshot was run at around 10 o'clock in the morning. So when I'm listing this snapshot, it proves that out is not in that snapshot. So I have to look in the next snapshot to find out if the file is there. I can see it, and then I can copy it to my current directory, which is I'm in my home directory, and this is how I can restore it. You don't need us to do it for you. Anything that you put in your home will be in a snapshot and is available to you. The only catch is how long ago the snapshot was created and what modification of the file you need. And as I said, we kept 8 daily snapshots and about 6 weekly, so you can judge from that which snapshot you want to restore from. The next item is actually probably what most of you will be using most of the time, is how to search modules and programs on HPC and what are the differences among them and how you can download them and how you can set your environment. Where are the programs and modules and how to access them? There are actually only really 4 areas where we do it, and you in addition can do it in your DFS or CRSP area, but basically you can install your own software in such a way that you put binaries in your home bin directory. This directory is already on your path, and this is why we recommend to use this one, because first of all, it's on a backup, it's in your path, you don't need to do anything else. This is added to your path already in bashrc profile file, and so no extra action on your behalf needed other than the installation. All system utilities and commands are in user bin, and they're also added to your path by default. Again, you don't need to do anything extra here. Now we're coming to library modules for languages like Perl, Python, or R, and we do this installation in opt apps, and the users will need to use language modules in order to access this specific language interface. And all other scientific applications are installed in 2 locations. It's either opt apps or data opt apps. And again, the users will need to use modules command interface for that. You may want to ask why 2 locations, what's the difference? The opt apps location is local to each compute node on the cluster. This is where we installed applications, and it is installed exactly the same way from exactly the same RPM, and we provide concurrency and consistency for that. There are some applications that we have to install in the area we call data opt apps. Why? Because this software is way too big to install on each node. So we have to install it on a different server and then make it available to each compute node. One example of such software is MATLAB. It's very big, it's gigabytes and gigabytes of installation, and we simply cannot install it locally. We try to do scientific applications locally when we can, because it provides an optimal access on each compute node. So how do you search for modules and programs on HPC? First, to access any program, it needs to be, its directory needs to be in your path, and you can check your path by executing command echo path. And here I broke the long line into multiple lines, but basically the content of the path are directories that are searched in order to find your program. And when we talk later about the modules, this is the path that we will be modifying with the modules. So right now, if I say which pip, because opt apps Python is in my path, it will tell me which pip I will be executing. There are so-called language modules, which are collections of variables, functions, and subroutines that are written in a specific language, such as Perl, Python, or R. So basically, these are language-specific code or snippet of code. And we need to search such modules using the language methods. And to access the language module, you need to use either Perl or Python or Py, whichever one you are interested in. And this is where we come to the environment modules. And sometimes it actually confuses people. We have language modules and we have environment modules. Just, I guess it's poor or overloaded word modules. It does mean both in effect. So what are the environment modules? You already are familiar with them when you were working on HPC, and we still use environment modules on HPC3 because it provides us with the ability to dynamically modify user environment via module files, so you can actually get access to a particular software. Each module file provides all the information that is needed to configure shell to use a specific application. For example, some applications require specific aliases to be set, others require a set of environment variables, and they also load dependent modules. When you execute command module eval, it lists all the software that we installed on the cluster, including their versions and sometimes including what compiler it was built with. If you are interested in general information for Linux about modules, take a look at the first link, and we highly recommend to everyone, please read our user guide that provides software tutorial and the use of modules. So environment modules modify and update your environment. You can use different versions of the same software, but not at the same time. Here, in the case one, I give you the rough outline of how you can use, for example, different versions of R. First, you check what R is available. You see that we have two modules for version 3 and version 4. I can load module for version 4. I verify that that's in fact R I will be using. And if you do module list at this point, you will see that all of a sudden, instead of just R, you see additional 3 modules loaded: OpenBLAS, Java, and ICU. And the reason for it is when we compile R specifically for this cluster, this was the dependency because some of the compiled R libraries right now depend on additional libraries provided by these modules. So for you, you only need to load one module R and don't worry about all the dependencies. We take care of it inside the module. You can then unload the module and load module R version 3 and so on and continue whatever you want to do. You can load and unload different software modules. One thing to remember is when you load multiple modules, you unload them in reverse order. And why? Because some of them actually modify the environment in certain way. And if you do out of order unloading, your environment may become inconsistent. So the only way to actually avoid inconsistency is if you load 5 different modules in certain way, you just unload them in reverse order, and that takes care of all the problems. In summary, modules provide search information and use commands. For search, you can use module available to list all the modules, or you can give a name to module available, which will show specific modules. Here is example R. You can do module keyword and provide the keyword that you search for, and sometimes different applications modules have same keywords for whatever reason. You can also get information about what this module will do to your environment. You can say module display, and it will show you what environment modifications will be done and provide the description of the module. Module help provides just the description, and we have already seen commands for module load, unload, and so on. One thing to remember, we do update software and we do update versions. Sometimes we have multiple versions of the same software on the cluster. For this reason, we recommend to use module load with the name and the version. As you see here, if you can load R without providing version, and you can load R with providing version, or any other module for that matter. When you say module load R and do not provide version, by default, that's the way the modules are built. It will load the very latest available. Let's say you're working with R right now, and this is version 4.0.2. And another lab requested that we install R module, I don't know, 4.5, and we do it. If you continue using module load R right now, by default, you will be getting the very latest version, and this is not necessarily what you want. So for that reason, we always advise users, please use specified version. This way, you're absolutely sure what you're getting. Now we get back to the language modules or libraries modules. So how do you know what Perl modules are installed if you're a Perl user? Well, there are probably more methods than 3. I'm listing 3 here, which are quite simple. First one, of course, for all of them, you need to load Perl first, so you have access to the Perl environment. And then you use install sh command, and then you do command L for listing, and it will provide you with the output of installed modules or libraries, which can be quite long. I mentioned that we have about 90 or more Perl modules. The second method is to use cpan. Those who are familiar with cpan, again, you need to load Perl module, then execute command cpan, and then execute command R, and that will give you information about what package is available, what its namespace, and what distribution file it was built from. Personally, I prefer this third method because I find it the easiest and it gives me exact information what's there. Note the only catch here that actually I need to know exactly what module name I'm looking for. Here in the third method, the first 2 lines are just basic Perl scripting lines that common use, and then I'm listing 2 other use lines. This is the actual names of the modules that I'm looking for, whether they installed or not. And the very last line says, say no errors. So what happens here, if, for example, Unicode map module is not installed on the system, I will never get to no errors line. I will get an error. But if I get to Perl printing no errors, then I am sure that Perl module that I'm interested in is installed. With Python is a lot easier. You can use command pip. You load whichever Python you want, and then you just say pip list, and it will provide you with the listing of all the packages that are installed and with their versions. You can do quick test for just one module. Again, you need to know what the name of the module is. If the command is successful, it will print nothing. But in the last example, I am asking to import some module that does not exist, and I will get a traceback error. And that's a very quick test of telling me whether this module is available or not. For R, there are also very few commands that one needs to use. Again, we load the module, we start R, and then we just say that find packages, and if the package is found, you will see the one type of the output, and if the package is not available, you will see an error message. So we come now to how to install the modules, and many modules can be installed in the user space. There is no single repository for downloading all the modules. I'm listing here the most important ones, and you can find many other ones in GitHub and so on, depending on the type of you're looking for and what you're interested in. In our user guide, we do provide instructions how to install R packages or Conda environments or Python packages using pip or Perl packages in your user space. So please take a look at it. And if you need one or two specific language modules, you can always add it to your user environment and use after that. And we're getting to the very last item, how to run jobs on HPC and what's the difference. In principle, HPC and HPC3 in summary are not that different. We had access to private queues before by the lab. Now we don't have any private queues, and users have access to all queues, and all queues are available to all. We used to have SGE, and users needed to write SGE job submission script and submit them with QSub. Similarly, on a new cluster, you need to create a Slurm job submit script and submit it with as batch command. And there is mostly one-to-one correspondence among commands, directives, and concepts. And the major difference is accounting, which we already touched. What are the common problem for the users that we have seen on HPC, and it may be translated to HPC3 as well, and how to avoid them? Some users submit really many jobs that have nearly exactly the same submit files, and the only difference is the parameters to their application. The best way to deal with it is actually to change this type of the jobs into an array job, and that will be optimal not only for the system but for you as the user, because your job have a better chance of running and you have a better chance of coordinating what is going on. Some users run heavy computational jobs on login nodes, and this is the example of inappropriate behavior because it adversely affects other users on login nodes. And of course, the fix is claim an interactive node or submit a batch job to run your heavy computations. Don't do it on login nodes. Some users don't set job environment properly and use too much of the resources, and the fix is use modules to create a proper application environment and only ask resources that you need. The example here is, let's say that you want to run, I don't know, some Python program. Most of the Python programs are actually single-threaded, but the user is often asking multiple CPUs for running single Python program, which means if you ask for 8 cores, you're running on 1 core and 7 are idling, but because they're scheduled right now for your job, nobody else can be using them. This is not efficient. So please be careful when you do that, and ask for more cores when in fact you need them. Some people are running out of space and not checking their disk orders. We recommend that users periodically check their disk orders and don't put too much in their home directories. As I said, the space is 50 gigabytes. There will be no extensions, no extra space, no nothing. You have to fit what you need for backup in those 50 gigabytes, and the rest you put on one of the DFS or CRSP systems that are available on HPC3, and additional DFS will be available soon. Sometimes users are not testing their job submissions. They submit the job and then go away. And once the job starts running, or even before it starts running, it goes into error state, which is already possible to get from the information on the queue. And in order to fix it, please test on the small input first. Don't submit a huge data file or multiple core requests if you are not sure whether all workflow steps in your scripts are proper. On the new cluster, you will be able to submit to the debug queue and run in there. Check all the names and variables that are correct, and check that all the directories that you're accessing or trying to access are in fact existing. And after submitting a job, it is a very good idea to always check the job status. People who already talked about it are not providing all correct information that we need when submitting their tickets for help. And please read our user guides. We actually outline exactly what information we expect to see when you're asking us for help, because this will allow us to give you help much faster. Well, let's get to the array jobs in SGE, for example. Why SGE, you might ask? Because many of you already have SGE scripts, and we can easily convert this SGE script into Slurm script in the next slide. So here I am running a job called my array. I'm submitting to a queue pub, and I'm asking just for one core. And because it was an old cluster, I'm saying use checkpoint restart. This line goes completely away on HPC3. The next two lines are the meat of the array job. Here I am saying run 100 concurrent tasks, and the total number of tasks that I am requesting is 2000, and they will be numbered from 1 to 2000. In the last two lines of this request, I'm saying I would like to get the standard error and standard R separately for each task, and this is how I want to name them. And here in the rest of the script is actually what is executed as commands once the job is landed on a particular node. Here I want to load my program module, and then I specify an input file. And because I want to run an array job and my program requires, let's say, just 3 arguments on the command line, and for each job I want different arguments, I created this file a priori. I call it input.txt, and each line has a specific content, what will be taken as variables. The line that starts with args on the slide shows how I can assign a particular number line values from the file to the arguments, and then at the very last line, I'm actually executing it. So essentially what you have here, whenever the new task is started on any given node, I am going to take the task ID number. According to that task ID number, I will take variables from that one input file and I provide them to my program, and then I will run my program. As you see here, instead of 2000 submit scripts, I can create just one submit script and one input file that will be parsed, and then I can run 2000 different array tasks with this job. Very similar thing is happening with Slurm. We have different directives here. Obviously, it starts with hash as badge. That's the directive for Slurm. We have job name. We submit to free partition. Here, I am again asking for 2000 tasks and running concurrently only 100 because maybe they're running long time. I don't really need all the output immediately. Again, I'm asking for the separate error and output files from each task. and the rest pretty much is unchanged, with the exception of I have to use Slurm array task IDs and job in place of what was there for SGE. But as far as the workflow of your command steps, that remains the same. So for many of you, it will be very, very easy to convert your SGE submit files to your Slurm submit files. And now we're getting to the last five or so slides that I am actually not going to talk about, because this is just too much without any specific example, and we provide examples of some of these commands in our guides. Here, I'm just going to show the comparison of what commands are when you're migrating from SGE to Slurm. Here are commands for login, for job submission and accounting, job deletion and status, for queue information, comparison of environment variables names between SGE and Slurm, job specification, what one needs to use as far as input, output, partition, and so on. And additional job specification here, such as name or mail. We ask our users to please be careful with the email notification. If you submit a lot of jobs and you ask for notification for begin, end, and stop of your particular job, then system will start emailing a lot of emails and overwhelm the mailer. You really want to be judicial about what type of events you want to receive notifications for. So be careful about the event notification. And we continue with the specifications here. Again, the job host reference, jobs dependency, if you want how many CPUs to ask. This is one very important difference, how many CPUs to ask. Please read the guides. We actually explain in detail how do you need to specify your CPUs and when do you need to ask for more CPUs depending on how much memory you want to use. So that will be in the user guides that I mentioned. With this, I think I want to stop because this is my last slide, and we can go to questions if there are any.
Oh, thank you, Nadia, for a great presentation. I think Catherine actually has a few questions if you like to just ask her.
Go ahead.
So you talked about interactive queues a few times, and I saw it briefly on one of the slides that you said you weren't going to go over. But for someone like I work on the command line a lot, you know, like Vi and stuff like that.
Mm-hmm.
And I know I shouldn't do it in the interactive node, but or I'm sorry, in the login node, but how do I do it now on HPC cubed?
So read our user guide, and we actually provide a specific example how you can request an interactive node. There are two types of commands. So one will allow you to get one with the terminal, and you can actually even forward X connection. So you can run GUI application if you want to. We have very specific syntax right there in the user guide.
Okay, do you know where in the user guide? Because I've looked through it multiple times. Maybe it's new, like in the past couple of weeks, but
Kate, I sent it to you.
okay, thank you.
Yeah.
I tried. And then is the debug queue accounted?
No.
Okay. And
debug
then
queue is specifically for such situations that, let's say that you have your workflow and you want to make sure that everything can start and so on, but debug queue is for jobs that run maybe 5 to 10 minutes, no more, and your job will eventually be killed. There is, because you're debugging, because you're trying to verify whether you're doing it right or not, this debug queue is not accounted. This is just for testing.
okay, and then you'd mentioned transferring data, obviously not doing it in the login node. Should we just do that in an interactive node, or is there somewhere special?
You can claim an interactive node and do the transfers there. Other questions?
So I have a question kind of related to Kate's question. So on the topic of interactive nodes, I know that I specifically will multitask and like run several things in different like interactive nodes on the HPC now, and then like come back to them, which requires something like screen or tmux, but those don't seem to work on the new HPC. And I was wondering if there are any plans to incorporate those.
Screen is available. What do you mean they don't work?
Oh, I have not been able to get it to work.
Well, why don't you then submit a ticket and provide all the information as we were talking about?
Okay.
Like, what
I
the-
actually just tried getting it to work again, and I guess like when I tried it a couple months ago, it didn't work. So now it does. So I apologize for that.
No need to apologize. Please, guys, don't take my words that when I said, well, we don't install all applications or whatever. We are trying to help. We'll be very happy to help with all your questions. There are no stupid questions, but we are asking you, when you ask us questions, give us all the information so we can act on those questions and we can give you the help. If you're giving us something very non-specific, we are unable to help. So please ask us questions.
Yeah, so this is one of the things that me and Remy are trying to do, because a lot of people going to have a lot of questions. I feel like the HPC people are not going to answer all of them through the ticket system. So we're trying to build like a Slack forum so people can post a question on there. And if someone that had experienced this before and had the question, they try to answer. And if not, and somebody else on the HPC can answer. But if you post the question through us, maybe you can have answer first, so you don't have to make other people busy.
We really can't go this way because in our ticketing system that actually provides us with the record what questions were asked and how we responded, and we can come back to it and so on. If we start responding in your Slack channel, we might not have enough time for
no, this is sorry, this is just for the student only. The student will help each other. Yeah.
Anyway, absolutely. Yeah, I think it's a great idea. We also, in the user guide, we provide information about the Google group that has been created for RCIC. You can use that. And there is RCIC Slack channel as well to exchange such information if you want to join it. But you can create your own Slack channel, and I assume that because you're all in specific department and you're probably dealing with a very similar type of software and programs, that you can share your information and gain more knowledge from each other. That's a fantastic idea. Yes.
Yeah.
It will be really helpful if someone can put the link to the Google group here so that people can have the access if you can. And also, I think Kevin had a question earlier. I don't know if it was answered.
Yeah, well, fairly kind of addressed it, but I just wanted maybe a quick word on what the status is of using Docker images and containers on the new HPC3.
There is no Docker images on NPC. Docker is not supported on HPC3. Docker images are not safe. We provide Singularity containers, but no Docker images.
So then if we have a piece of software that normally comes with a Docker image, we still have to submit a ticket to have you guys convert it to a Singularity container?
No, we are not going to convert it to Singularity. What you will have to figure out how to install your application, or if we can maybe install this application for you on a cluster, if that application is required by many users. We will be happy to assist with that. But we are not going to start converting Docker containers into Singularity containers. That's not going to be usable for us. I'm sorry.
No, thank you.
And when you mentioned group requests for software, how should we go about doing a group request?
Oh, it's just very simple. Let's say that you're working within one group, and you and other students and researchers, you all want to use new software. You decided that 10 of you want to use, I don't know, Salmon 1.5. You write a ticket to us and you say, well, we're from this group of PI so-and-so. We have Salmon 1.1, but we need to use Salmon 1.5. And we will honor this request and we'll try to install it. In fact, this is most of the time, that's what we're trying to do. If really a group of users is asking, we try to build the software because it makes the most sense instead of everyone trying to do it in their own area.
I think Gabriella had a question earlier. I don't know if she's still here to ask her question. If not, I'll just read out her email.
Yes, please.
So I think she has a question regarding the group request as well. So she said that they have an account for each lab, but they're also part of a bigger projects that involve collaborations with other labs, such as in case of Model AD, a consortium to study Alzheimer's disease, and they're interested in having a consortium account to charge the computing instead of each one charging their own lab. So how do they do the same thing? How do they generate?
So that's a little bit different. Right now, let's say that Gabi is in a group of one PI, and that PI has a specific allocation of the computing hours, and we have given this group allocation and the group is using it. And let's say Gabi has another collaborator with another group, and that person also had been given an account and using their lab account and personal maybe and using it. We can't really combine these group accounts, and we can't really manage it for them into one collaborative. If they really want to do something like that, what they will have to do is ask from OIT for a separate UCINet ID. We can create a user for this UCINet ID, and as far as their respective PIs and groups, what number of hours they want to put into that account, all of that additional either purchase of the hardware or purchase of core hours will be added to that account, and then people will start writing from that account. But that can be very messy, because now imagine that 10 different people are trying to use the same account and run something from it. That may not be the best situation, but we are not going to manage right now these collaborative accounts, because it creates much more complication for us in terms of queue management and accountability, and we really don't have resources for that.
So as a user, I only have access to the account of my PI.
No, that's not correct. So let's say you're a user, and let's say you're a PhD student. You have a PI. So you are given 1,000 core hours as every user on HPC3, and you can use it. This is going to be your balance, and this is going to be used when you are asking for standard queue. You are also in a specific PI group, and you can use that PI group account for your jobs, for account or jobs. You may be in 2 or more groups. It depends on the user. But you can also use a free queue without any accounting whatsoever. And this is what we recommend for people. When you're just trying out something and you are not sure whether you're right or wrong and whether you created correctly your workflow, we recommend to use a free queue until you've proven to yourself, yes, this is what I want to do, this is how I want to run, and this is actually how many resources it's taking. And then if it comes to a point where specific job is very important and you don't want to have a chance that the job is killed, then you submit the job to your standard queue in your own account or in your lab account.
Okay. So,
otherwise, run it in a free.
So for example, I think there's a lot of us on here who have PIs with collaborations. Like, for example, I'm in the Mortazavi lab. We have multiple different projects with multiple different grants, each of which has a certain amount of allocation for our HPC cube time, essentially. But because it's all part of one account under the Mortazavi lab, I could essentially run out of my allocated amount and go into someone else's. So is there a way to like monitor basically how much we're using as individual users or for a specific project?
Yes, we have information how to use Slurm commands to see how much have you used in what account. S account, yes. You can do that. And it's up to you to choose whichever account you want to use. If you have access to multiple lab accounts, multiple Slurm lab accounts, you provide this account information when you submit your script, and that's against that account your core hours will be subtracted. But it's up to you to choose, because you are the only one who knows which project you're running for and which data you're using and against which project you want to charge it. And in addition, sometimes the PIs can reallocate and can say how many more hours a particular user within the group can actually use.
Okay, but the accounts are all based off of the PIs, not based off of projects. So for
Correct.
example, for the Model AD, which has multiple PIs across multiple campuses, like they would still have to be accounting to their individual PIs.
Multiple campuses, we do not provide access for people outside of UCLA.
I mean, like MedSci and BioSci, for example.
We don't combine PIs accounts, and the reason for it is also some of the PIs have bought hardware, some of the PIs have bought additional core hours. This is what they deposit. We deposit it in their accounts, and this is what they need for running whatever jobs for their groups. We cannot possibly start combining different groups' accounts. So if there are multiple PIs and groups that want to talk about it, then right now we don't handle these situations, but we probably will need then create a meeting with the PIs and figure out what exactly do they want and how they can allocate maybe hours for that and see if we can accommodate that. But as a default, it would be too much of overhead for us, and we are very, very small